the last thing we are going to see in this IP addressing topic is the difference between private and public IP and what is the reason for this. Now you can see the table very clearly, which gives some more better idea on why we need to the differences between private and public IPs. Let me take an example here to understand why exactly we need to have a public IP address and private IP address classification. So if I take an example, I got a router connecting to my local area network, and in my LAN I got some hundreds of users accessing internet. So probably to provide internet access, I connected my router to ISP, and from ISP I'm able to access internet. So this is where I'm able to access internet. Okay, so now the user sitting here, maybe the user sitting here, he send a request, he want to go to yahoo.com, let's say. So there is a DNS server on the internet, so probably we need to maintain that information. In my PC I will have the IP address, I will have the subnet mask, I will have the gateway address. Gateway address means the address of the router, and then I'll also have the DNS server information, which is generally you'll find when you are accessing internet. Like if I just try to see here TCP/IP properties, you have all the options. So anyway, I'm connecting to internet via wireless here. So if I just go to my status, or if I just go to status, if I go to details, you can see this is the IP address of my PC, this is the subnet mask, this is my gateway, and you can see the DHCP server, DNS servers. So actually my gateway is acting as the DHCP and DNS servers, all these things. So you have to provide this information. Based on that information, the main thing, DNS server, let me give some idea on DNS server here. DNS is one type of service which is going to convert your name to IP address. So DNS server maintains the database where what is the name. Like whenever I want to access yahoo.com, we are not going to type the IP address because you cannot remember the IP address of each and everything, just like your telephone directory. So if you are using your mobile phones, you have the contact name, and that name is saved with some number. Okay, so based on that number, if you want to speak to that person, probably we are not going to remember the number. Mostly even I don't remember many numbers, because we have a name, we try to search with a name and we dial to the name. But when you're dialing to name, it is actually dialing to number. The same job DNS server will do. So it's something server related technologies. We don't do much on these things here because our main focus will be on the routers and switches. That is our main focus here. So whenever you are trying to send a request, so Yahoo server is somewhere on the internet. Let's say the IP address of the Yahoo server is 202.111. So now the request goes to DNS server. DNS server will tell the IP address, which means when you are sending a request, the request reaches the router. Router sends it to ISP. From ISP, it reaches your Yahoo server. So now the user who has requested, the IP address of that user is 192.168.1.1, which means who is requesting the page? The source is 192.168.1.1 and the destination is 202.111. So when you send the packet, now the destination has to reply, right? It has replied to 192.168.1.1. But the problem is, internet is a public network where everyone is connected, right? So internet is a public network, everyone is connected. So there may be a possibility that there are some other users in different company, maybe in a different country, maybe somewhere, even I'm not sure where they are, but also using the same IP address. But now the question is, this user has to reply to 192.168.1.1. Now the question is, will it reply to this address, will it reply to this user, or it will reply to this user, or it will reply to. So now there is a possibility of confusion now. So this type of scenarios, and you cannot say that don't use this IP because I'm using it, because the IP addressing scheme is common for everyone, and probably there may be users on the internet also using the same IP. So now there may be a conflict happens. So this is a general problem. To overcome this problem, so when they classified IP addresses, they also said, okay, To overcome this problem, we are going to create some IPs, and those IPs will be referred as public IP addresses. And those IPs are recognized on the internet. If you want to go to internet, we need to use these public IPs, and these IPs are recognized on the internet and given by the service provider generally, and service provider get from INA, and they are globally unique. Globally unique means, suppose if I'm using some public IP, so let's say they said that if you want to go into internet, you cannot go with this IP because this IP is not recognized on the internet. You have to go with some IP, and that should be a registered public IP. And let's say I'm using 50111 here. Now this IP is registered with my company, with my user, as long as I'm paying to service provider. Just like every year you have to renew it to use this IP. Similar way, now once this IP I'm using, this IP is registered with my company, so no other organization, no other user will be assigned the same IP. Similar way, when this user want to go to internet, he use some other IP. Let's say 100.111 is IP. Similar way, when this user goes, he use some other IP 50.111. When this user goes, he uses some other IP. Let's say 100. Let's say 150. Some address. Just I'm taking some random addresses 150.111. So every user, when they go to internet, they use their own registered public IPs. So everyone uses their own registered public IP addresses given by the service provider. And to get this IP, you have to pay to the service provider. You have to pay to the service provider every year based on the lease. So you need to pay to the service provider. And they are registered IP, registered with only specific customers. But now the question is, in case. So that's something which generally happens. But now the question is, let's say in my LAN, I got thousands of users. And if I want all the thousands of users in my company, I got thousands of users, and I want to make sure that all my thousands of users should go to internet simultaneously at the same time. So getting 1000 public IPs is something which is not possible in today's networks, because a company may not be able to afford 1000 public IPs, or maybe that many IPs are not available. So that is the main reason actually why there is a shortage of IPs. Every user want to go to internet, which means every user you need to have a separate registered public IP. So that's the reason to overcome this solution. They said, okay, in the LAN we can use a private IP addresses, but when they go outside, they go with a registered public IP and using NAT. And this process of translating your private IP address to public IP address we call as NAT, network address translation. Means in the LAN you can use private IP addresses which are free of cost. You don't need to pay to anyone. You can simply use these private IPs within the LAN, and I can use thousands of private IPs in my LAN, and when they go outside I can send them with only one public IP. And this process of translation, so using NAT, what I can do is I can translate more than 60,000. I can translate more than 60,000 private IP addresses can go to internet with only one single public IP. So because of this, we are still surviving with IP version 4. IP version 4 is still in use only because of NAT and some other subnetting concepts. So based on this, they classified. So we got two types of addresses: private addresses and public addresses. So this is the main reason actually. So these private IPs are not recognized on the internet, which means if you want to go to internet, you should have a compulsory a public IP address. Generally, private IP is decided by the administrator, so they are unique within my network or within my organization, and I don't need to pay to anything. And they are unregistered IPs. Unregistered means, like in this example, there may be a user also using the same IP address. So because they are not registered, not a problem, because when they go to internet, they go with a registered IP. So this is what we have in our range. Out of this range, I have some range here. In this range, we just have only few addresses as our private addresses. There are only few addresses which are private as per our requirement here. This is a list here. Out of this, whatever the addresses we have, in A class supports more than 126 networks. You can see around 126 networks. In that 126 networks, only one network is private, and that too it is only 10-dot network. So only 10-dot network is private, remaining all are public. So anything starting with 10, you have to understand it's a private IP, and anything other than 10 in the A class, you have to understand it is a public IP. So similar way, B class network supports 16,000 addresses, 16,000 networks. In that, there are only 16 networks which are private. Means anything starting between 172.16 to 172.31. Means 172.16, 172.17, 172.18, 19, 20 till 31, or your private IPs. And whenever you see any of these addresses, you have to understand it's a private IP. Similar way, in the C class, you got more than 16 million networks, but in that, anything starting in between 192.168.0 to 192.168.255, which means in simple we can say anything starting with 192.168. We have to understand that these addresses are your private addresses. So let's take some examples to classify. Now I'll take one example. I'll say 150.12.10.10. Now this address is a private IP or public IP. So it's a B class. In the B class, this is private IP. So public IP is very big, so it's a public IP address because it is not coming in this range. Similar way, if I say 192.16.10.10, so this is also a public IP because it's a C class. In C class, anything starting with 192.168 is private and remaining all are public. Similar way, if I take 192.168.10.10, so this is your private IP address because it's exactly come in their range. So it's very important to have a very clear idea on what is a private IP, what is public IP. So you have to remember this range, and whenever you see any address, you should be in a position to identify whether that particular IP is a public or private IP addresses. Okay. So finally, default gateway, we'll get into this. Default gateway in general represents a router address. So we'll see more in detail about the gateway and gateway addresses when we get into some routing concepts. Okay. So that's what the complete overview of your IP addressing. So this very important to have very good foundations on IP addressing, IP version 4 addressing. You should have very clear idea on the formats, octet format, and then the ranges. You should remember the portions, and just an idea. You can not compulsory to remember these exact numbers, but good to know the exact figure. Okay, how many networks each A class supports and how many hosts per network. Each network supports how many hosts. So similar way, the reserved addresses which are not used, which can be used, like we cannot use multicast address, this class D address, class C address. Even we cannot use network ID broadcast address. And subnet mask, importance of subnet mask is very important, especially when we do some advanced IP addressing classes, like when we get into subnetting, where we are going to manipulate some subnet mask. So probably we'll get into that next contents. And finally, very good understanding on what is private and what is public addresses, and what's the reason they are classified, and remembering the range of private IPs, because public IP range is very big. So we remember only private IPs. Anything beyond this range, out of this range, are considered to be as public IP addresses.